Hello all, this is Vivek from Kesha Memorial Institute of Technology. Today I want to share something about my ongoing project on robotics. Me and my team Curious Perseverance making a planetary rover with a movable robotic arm. The main objectives of our project is to make rover autonomous and using robotic armor for picking and dropping operations. I want you to know more about the main components of our rover. Those are Pixoc, DC motors, Sabertooth, 6 degree of freedom robotic arm, stepper motor, Nvidia Jetson Nano, and LiDAR and some camera. First of all, I installed the Mission Planner software, which is a free and open source, which act as a ground control station. It contains different types of firmwares like Arthur Rover, Arthur Plane, and Arthur Copter. But we are using Arthur Rover software for our rover. And to know the movement of our rover, we simulate our rover by using Mission Planner software. Here we can make our own mission plans and we can mark our waypoints so that we can know more about the movement and the orientation of the rover. In this slide, we will talk about Pixoc. Pixoc is an open source autopilot system that works by running a software on the microcontroller. First of all, we connect the Pixoc with the machine planner to install the Arduino firmware, and then we can connect different type of sensors to the Pixoc, and we can connect compass and motor driver to the Pixoc, so that it acts as a microcontroller. My rover consists of six wheels, six DC pursuit motors, which are nearly 500 RPM each, and it contains six shock absorbers. My rover can capable of lifting 6 kgs of weight. And the next slide, we will learn about the Sabertooth. Cybertooth is a dual motor driver module which is used in robotics, and it uses pulse width modulations to control the speed of the motor. It uses different variety of input signals including serial and analog signals. DroneKit is a Python-based software development kit. It is used to write the code for moving the rover while testing, and here we used to communicate with the rover by using different types of protocols, just like Mavlink. And the next very important thing we have to know is the steering type. Here we uses skid steering because it is very much preferable for our rover body. In this type of steering, the wheel speed and the speed of the motors will play a major role. I use a robotic operating system for developing rover application. It contains different types of libraries and packages. I downloaded the version ROS Melodic in Ubuntu 18.04 version. It consists of Mavrus package, which provides a communication bridge between the ROS and the Mavlink communications. Here we write the code for moving our rover and for our robotic arm. We uses RVs for communicate for simulation of a rover and the robotic arm. In the next slide, we'll learn about the Nvidia Jetson Nano, which is a graphical processing unit which act as a heart for our rover, which makes our rover autonomous, which can take its own decisions based on the situation. It is used for running AI algorithms and many software applications, autonomous navigation, object detection, and recognition communication. And for all applications, we use the Nvidia Jetson Nano. Now we will talk about the robotica. I used 6 degree of freedom robotica, which consists of 6 servo motors, and these all 6 servo motors are connected to a motor driver, but this arm cannot pick a object which is at a height. So that I created a platform which can make the robotic arm to move upward and in downward direction, which can move up to a height of 1 meter. So my arm can pick an object which is at some height. This is so similar to the mechanism of lift. I use it one stepper motor. Here you can see the stepper motor for lifting the platform to upward direction and to move in downward direction. Here I use it a Arduino UNO board for writing code and running the code. I have to do many things to make my rover completely autonomous. Some of them are I have to work with SLAM algorithm, which helps my rover to make maps and explore places. And I have to work with the visual audiometry method, which is used to estimate the orientation and position of my rover, where the data is taken from the LiDAR and cameras. I added some videos related to the rover while testing, watched them for better understanding, and thank you for